Greetings and salutations, my hard-working pre-calculites. We're continuing with our Algebra 2 review, and this lesson is on polynomials and factoring. Just a quick lesson over this, and you have to take these notes on your own paper. I didn't do a worksheet for you because there's very little notes that has to take place. I'm hoping that you got practiced up with factoring, quadratics in your Algebra 2 class. I'm just going to hit the high points. So here we go. Some polynomial facts. The degree of the polynomial is the highest power on the variable. So if they ask you what the degree is, you look for the highest power on the variable. That's the degree. Standard form of a polynomial means you have to write the polynomial in decreasing powers from left to right. So for example, a quadratic was x squared plus 3x plus 2. The powers go down, 2, 1, none. And polynomials also have to have positive integer powers. Positive integer powers means there's no fractions and there's no negative numbers in your powers. Some special binomial products are the difference of squares. A squared minus b squared factors is a plus b times a minus b. The sum of cubes, this one you might not be as familiar with, but it is a factorable thing. A cubed plus b cubed is a plus b. A squared minus ab plus b squared. The way I like to remember these sum and difference of cubes, if you notice with a cubed minus b cubed, it starts off a minus b, a squared plus ab plus b squared. There's two ways that make these things easy to memorize. First off, a cubed plus b cubed. It starts with an a plus b. See how the pluses match? A cubed minus b cubed, it starts with an a minus b, so it's like you drop the cubes right off, and that's your first part. Then there's only one minus, so on the next one it's a squared minus ab plus b squared. You got a plus b times a b plus b, that's going to give you a plus b cubed. This one, the minus is in the first one, so these two signs are plus there. Anyway, we'll get to an example of how to use that. Expanding the products, these are shortcuts so that you don't have to write things out like x plus 1 times x plus 1. If you get the hang of this, this can save you some time. So a plus b quantity squared, a squared plus 2ab plus b squared. A minus b squared would be a squared minus 2ab plus b squared. And perfect cube, this one you haven't used a lot, but the way that you probably learned is you did like a plus b and then times a plus b and then times a plus b, and you multiplied it out and all that kind of stuff. So this is a shortcut for that. A cubed plus 3a squared b plus 3ab squared plus b cubed, and then the minuses are on the first and the last one for a minus b cubed. So you might want to pause it and copy those down. One thing I do want you to see is that it starts with an a cubed and the next term is a squared, and then the b appears, and then it's a to the first and the b is squared and then a b cubed. So as the a comes down, the b's go up. Alright, let's do an example of expanding the product. 3x plus 4y quantity squared. The old way was to take 3x plus 4y times 3x plus 4y and FOIL it out. However, we're going to use the shortcut, this expansion thing, where we have a squared plus 2ab plus b squared. So that means we're going to square the first term, and then 2 times the product of these two things. So it's going to be 2 times 3x times 4y. And then we're going to square the last term. So it's going to be 4y quantity squared. Be careful when you're squaring these that you also square the number in front. So we end up with 9x squared plus 2 times 3 times 4 is 24xy plus 16y squared. Alright, that's it. If you FOIL it out, you can do that and you'll end up with the same answer, but if you get used to this formula, it saves you a little bit of time. Now this one, cubing the formula saves you much time. So the formula for anything cubed was a plus b quantity cubed, and I color coded it so the a's are green and the b's are blue. And I'm going to label the u is going to be where the a, everywhere the a is, the u is going to be placed, and everywhere the b is, you're going to put a 3v. So I'm going to have u cubed plus 3 times u squared, and then the b, remember that's 3v, so that goes in place of the b, plus 3a, but the a is u, so it's 3u, and then b squared, so that's going to be 3v quantity squared, plus b cubed, so that's plus 3v quantity cubed. Then you just simplify that out. That's going to be u cubed plus 3 times 3 is 9, u squared v plus 9u squared v plus 3u, then you square the 3v. That gives you 9v squared. 9v squared times 3u is going to be 27uv squared. And then 3v cubed is going to be 27v cubed. So that does save you some time if you remember foiling it out and then doing a 2 by 3 multiplication. Factoring, this is a sum of cubes. There's our formula, a cubed plus b cubed. And again, I've got it color-coded to help you see. We know this is z cubed. That's going to be where the a goes. And what number cubed is 64? That's 4. So we're going to think of this as 4 cubed. So 4 is what's going to be the b. So everywhere there's an a, I'm going to put a z. And everywhere there is a b, I'm going to put a 4. So this is going to become z plus 4. And then I'm going to have a squared. That's going to be z squared minus a times b, which is going to be z times 4. So 4z plus 4 squared, and close the parentheses. If I simplify that out, I would end up with z plus 4 times z squared minus 4z plus 16. Now I like to do a double check on these, and I just make sure the first guy, z times z squared, gives me the z cubed, and the 4 times the 16 gives me 64, which it does. Alright, when you're factoring this type of equation, it's a quadratic rather, 10v squared plus 23v plus 12. I'm going to do this by putting two factors that multiply to give me 10v squared that go here, and two factors that multiply to give me 12 go in these two spots. I'm hoping you remember breaking a quadratic up into a factor of two binomials. So there's going to be two terms here and two terms here. These two have to multiply to give me 10v squared, and these last two have to multiply to give me 12. But you have to make sure that the outer and the inner add up to 23 in the middle. So if I'm trying to find factors of a times c that sum to b in the middle, I picked this one because most people have trouble when they have numbers in front and they're not prime, and in this case they're not. So if I look, 10 times 12 is 120. I multiply these together. Then I'm going to look for two factors of 120 that add up to 23 in the middle. So 5 times 24, that does not work. So 6 times 20 is 26, that doesn't work. 30 times 4 doesn't work. 15 times 8, bingo. 15 plus 8 is 23, and 15 times 8 is 120. So I know that if I arrange the factors of these guys, it'll work out. This tells us what the outer and inner product have to be. One of these has to be 15v, and one of them has to be 8v. So I'm going to try to get 15v plus 8v for my inner and outer terms. 8v, and I'm doing 15v here. Then remember, I look for factors of 10 that'll go into 15, so that's going to be a 5. If this guy's a 5v, that means this guy's got to be 3 over here, and 3 does go into 12, so we're copacetic. And then that kind of finishes everything out. So this guy has to be a 2v, because 2v times 5v would give me the 10v. And then 3 times 4 would give me 12, but 4 times 2 is 8v. So it all works out. And then we put the plus sign, since they're both plus. This is a plus, this is a plus. This sign over here, recall, means both signs are the same. This sign means they're both positive. Alright, so that's just a quick factoring for quadratics. I'm hoping you guys are practiced on those. Factoring by grouping. This is most used when you have 4 terms. Sometimes you can use the factoring by grouping to do the quadratic that I just did. What you do with factoring by grouping is you group them 2 by 2, then factor out the greatest common factor of each of those little groups. Be careful when you group it that this is a minus, you have to change both of those signs. So in this first group, x squared is a factor of both those guys, so I'm going to factor him out. And I'd have 2x minus 3 there, because 2x times x squared would give me 2x cubed. X squared times 3 gives me 3x squared. In this there is no factor, so we just put a 1 out there. 2x minus 3. Now, if you notice, both of these match. That means they're a common factor. So you can actually factor that out. X plus 1 times the quantity 2x minus 3. So whenever they match like that, you can rewrite it and it's factored. All right, so I hope that refreshed your memory on factoring and polynomials, and I will see you later.